Hello, ladies and gentlemen. This is attempt number 2 because I didn't have the volume turned on the last time I recorded this. So it is July 1st, 5:38 p.m. It's 2025. It's the future. It's horrible. But forget about that. Let's talk about the engine. So I've basically done nothing. Let me just boot it up so I even have an idea of what I'm talking about. So I got perlin noise generation again. As you can see, it's not the simplex noise. Simplex noise was really expensive the way I was doing it. I'm just generating like a flat block right now because the eventual goal is to rewrite, make a separate path through the voxel meshing so I can like update it in real time, and I'll show you why. So this whole past month I've been working on just basically UI sliders. So you see we have I don't know what you saw last time, but we have this like performance profiler. I can like click into it and you've probably already seen that. Let me unpause it. But I'll click this Perlin noise generation thing and yeah, so there you go. It looks really freaky, but it already spoiled the whole surprise. The fun part is over. Okay, so anyway, this is Perlin noise where we're doing fractional Brownian motion where we're layering multiple different scales of perlin noise on top of each other and blending together the colors. So usually, like, it's just black and white bloopy noise, but when you layer it together, it looks more cloudy and marbly. It looks more interesting. It looks so pixelated because we are sampling at a lower resolution, that we're sampling like every 8 pixels in the X and Y direction. I can increase the rate at which we sample it and you see it gets smoother, but at the cost of higher performance. So like now, every frame as it ticks past, it's taking like maybe 2 frames, 120 cycles to render anything. One cool thing about my UI system is that I can, like, when I was working with IMGUI, I would slide the sliders up and down, but it was always really hard to get back to the original position, like exactly to the original position. So one of the benefits is of doing everything from scratch is that you can just hard code it. Like, okay, when I right click it, it'll just jump back to its original position that I coded it with. So that's pretty nice. So yeah, this is a fractional Brownian motion. We're layering multiple octaves of noise, and you can get more interesting. So you can see that like I can change the color. It's like, imagine if this is terrain height, or like if you're looking at a Minecraft map. So you see like it just looks like a bunch of clouds right now, but then let's start adding color to it, and let's even increase the water. So like we just have an imaginary water value. If you're like below the water level, which we can rise with the slider, then it's all ocean. Otherwise, there's little islands, and you can see like the islands. Maybe you can think of this like a height map where the white parts are like snow-capped mountains or like desert areas that are away from the water. It's all banded. Like there's no actual values aside from like the height that I'm using to color it. So, but it still does look rather interesting, and you can see that it's tiled. It's tiled in every direction. We can keep scrolling in the X direction and the Y direction, and we can like adjust the Z value. It's like what's happening with my simplex noise in the background. You see all that? I'm like pushing a 3D volume of noise through this little quad. We're doing the same thing if I scroll this Z parameter thing. And one cool thing that I did is that there's a thing called a bitmap, a .bmp file, if you've ever seen it, and it's like a little PNG. It's just a little image file that you can write out. So let me let me go to the directory for the project where we actually saved this texture. It's called tiled noise. It's tiling. It's perfectly tiled. Let me please load it. Okay, so yeah, so you see that? That's basically what we just saved right here. I can adjust the Z parameter. Let's just make it all blue just to show you as an example. So we'll reload the tiled noise, and there you see it's just the deep ocean. It's pretty cool. So the next thing I worked on was let's work on domain warping, where this will look really fucked up. So I'm rendering at a higher scale. So this is called domain warping, where you give input to. I'm using value noise for this. There's a bunch of different noise functions. You can look them up. There's perlin noise. There's simplex noise. There's value noise. There's Voronoi, cell noise. I haven't gotten that working yet. But anyway, this is domain warping, where you give values, coordinates into the noise function, you receive an output, and then you put that output back into the noise function, and that's called domain warping. And so you can see I can shift it in the X direction. We're kind of moving in the positive X direction. We can move in the negative Y direction. We can also like scroll the offsets in Z. I'm sampling at a very low resolution because as you can see, it is very expensive to run this. And as I increase the rate at which we sample, sorry, it jumped right there. Let me drag it all the way down. You see it just starts to chug the performance. Like maybe we're running at 0.25 frames per second now, but it looks very pretty. Here, let me, please. It hardly even recognizes my inputs anymore. It's so laggy. Okay. Okay, perfect. Okay, so, dude, it jumped. What the fuck? Please. This has never happened to me before. It might just be too laggy to register my inputs. Please. That is just crazy. Okay. Okay. So, but you can see that it's very laggy. We're running at like 0.25 frames per second. So, but the texture looks very nice. So let me just spam click this like export to BMP thing, just so we can try and save it. And we don't really need this anymore. We can shut it down. It doesn't matter. Who cares? Please turn off. It doesn't matter. Whatever. Okay. So, and then we'll look at the tile noise. And look, we have a cool, interesting texture to apply to a voxel, maybe. You know, like imagine Minecraft textures, they tile perfectly in like the X and Y directions. We can do the same thing here with our randomly generated noise. So the next thing I was thinking of is SIMD optimizations, just to make it easier for me to develop this and get it faster so I can more easily tweak the parameters, hook it up to the voxel generator. But SIMD, I got it like working 2 times faster, but it's like 10 times slower on AMD versus the Intel processor. So the compilers don't even work right when you're trying to profile your own code, so you can't really do much from there. So the next step is just hooking it up to voxel generation, but that'll take like another month because I'm so lazy. But anyway, that's blah, 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 blah. Thanks for watching. Bye-bye.